Hey everyone, thanks for clicking on the video. I'm a self-taught developer and I'm working through as many LeetCode problems as I can, and I'm sharing my process and that journey with all of you. What I hope you find in the video is one, a working solution to the problem. That way, you can hit enter and submit on LeetCode and get that little dopamine hit. It says, hey, you did it. But also, I hope you get an intuitive understanding of how this problem works in a way that requires the least amount of memorization as possible. That way, if you run into it in the future, you can reason your way into the correct solution again using first principles and problem solving skills instead of just rote memorization. So let's go ahead and look at this problem here. Problem's called two-sum. Why is it called two-sum? Well, we're looking for two integers inside of an array. It's going to be a Python list for us, but sometimes those are called arrays. And what we want to do is we need to return the two indices that add up to the target variable. So we're going to be looking for values that add up to a target, but we're returning the indices or the positions in the list. We're given some extra information. We're told that each input is only going to have one solution, and that's useful. And then also, we're given a piece of limiting information. It says we can't use the same element twice. And with those few pieces of information, we have what we need to attempt this problem. I'm going to do it in a Jupyter Notebook first, just because I think it's a little bit easier to work with. And then after that, we'll come back over here to LeetCode. All right, let's hop into this problem here and see what we can do for a first pass solution. So the most obvious thing we could do is we could do a brute force solution where we could iterate through nums with a nested for loop and compare every element to every other element. Now remember, we cannot use the same element comparing it to itself. So for example, if target were 2, we couldn't compare this value right here, the 0th order element, 1 and 1. We couldn't return that as an answer, so we need to ignore that case. So basically, if x is equal to y, then we need to break out the loop. Otherwise, if the actual value of the arrays add up to the target value, then we're going to want to return our result. Now, I'm not writing a function here because we're not going to reuse this, and we're just visualizing some things here. So I'm just going to print the answer instead using an f string. Obviously, if we were in LeetCode, we need to write an actual function to do this. So the solution is, and then we'll just return x and y. All right, let's hope that works. Okay, and it does. So if you look, the entry index 1 and entry with index 7 do add up to the target variable 9. Now the interesting question is, why is this not efficient? I mean, maybe we know from just rote memorization that nested for loops are not the best approach, but I'd like to take a more intuitive approach and try and figure out what we're losing with the solution and how we can naturally transition to a better one. In developing that intuition, I think the line of code that really demonstrates why this is suboptimal is this line of code right here. So what we're doing is we're adding up the two numbers from the array nums, and we're trying to see if they equal a target value. We're really throwing information away every time we go through this loop. Now, that information isn't totally useful right now because we have a binary comparison. We're checking, hey, do these two numbers equal the target that we're interested in? And if they don't, well, we move on and we don't save anything. But imagine for a minute instead, if we had some kind of operator here that did some kind of like how close operation, which is real abstract. We checked and we saw, hey, when we add up these two numbers, how close are they to the target? The syntax is kind of funny. I can move this over here so it's a little more clear. Imagine this were like a function, right? We took in these numbers as elements and we stored that value. That way, as we looped through in the future, we could look back and see, hey, did we get anything that was close to this value? And that's really abstract and maybe you don't see where I'm going. There's a really simple operation we can do. In fact, it isn't abstract and is not a function. Instead, we could just do a subtraction problem, right? So if I just comment this out, what if instead, at every time we went through nums, we stored some value that was the value of target minus the nums of the current index. And if we had that value, then what we could do is we could look back every time we find a new number and check, hey, is that number, is that answer to the subtraction problem the one I'm looking at right now? And so, every time we get to a new element in nums, we can look back at all of the possible answers we've generated and check to see, hey, do I have the answer right here? And if we're intelligent about how we use a data structure, if we use a dictionary, something that gives us a constant time lookup, you might have heard these called hashmaps in other languages. They're called dictionaries in Python. We can effectively loop through nums one time, store this information in a dictionary, get constant time lookup time, unless the dictionary is just gigantic. And we're not, we're told the input size on this problem, our dictionary is not going to be gigantic. We can change this from a big O of n squared problem to a big O of n problem. It's going to be a pretty exciting speed up. So let me show you how that's going to work. So the first step here is we need to define an empty dictionary at the top of our loop. I'm calling mine sdict. I'm thinking in my head that stands for subtraction dictionary, but I'm sure you can think of a lot of fun names for this dictionary. And then what we're going to do is we're going to enumerate through nums. So for the index and the element in enumerate nums. By the way, if you don't know how enumerate works, what enumerate does is it creates, as you can hopefully see here, an index that is an integer value that represents the position in the Python iterable, along with the actual element that is being unpacked. So for the index and the element in enumerate nums, what do we want to do? Well, we want to check to see if the target value minus element is in our dictionary. If it is, we have our answer. But I'm going to skip that for a second and finish out the other half of this if-else statement. If it isn't in there, then what do we want to do? Well, we want to take our dictionary and we want to store the current element in there along with where it is in our array. Because remember, while we use the elements and the target value to find the answer to the solution, what we need to return are the indices, so the position in the array. Okay, and now just to finish out this last little part here, if we do find the answer, what do we want to return? Well, it's the dictionary where we're finding the first element, which is the solution to the subtraction problem. And then, of course, we have to return the current index, which is the other half of the problem. All right, moment of truth. Let's hit enter and see if we get the right answer. Indeed, we do, 1 and 7. So remember, position 1 and position 7 in this array. Now that we've got our answer, we can take our code back into LeetCode. By the way, you can develop in LeetCode itself if you like. I'm just too cheap to pay for the extra test cases. And the only thing we're going to have to change is we need to add a return statement instead of our print statement. And then let's test our code real quick. All right, we passed the first test case. Let's submit and hope that we get an accepted return. And boom, would you look at that? We got the right answer. So just to summarize here, we went from a big O of n squared solution using a nested for loop, working through 2 Python lists, sometimes called arrays. They're actually a little different, but we can talk about that some other time. And with just a real simple trick, we have turned things into a big O of n solution. One final thing to think about, a thing that I like to think about, and LeetCode kind of does too, is to think, how would this problem change if there were small differences in either the input data structures or the question being asked. If you don't know what I mean, think about it this way. What if we were guaranteed a sorted input for our nums Python list, the input array? Would that change how we try to solve this problem? What if there were multiple solutions to the problem? Remember, we were given that condition before that there's only going to be one solution. What if we could have more and we had to pick the first one in the list or the last one in the list? Now, I'm not saying that you go through and actually change the problem and resolve it a number of times, but try to think about that because it will help you naturally transition between different problems. And of course, different LeetCode problems do this very same thing, and hopefully we'll get to them. We'll get to look at 2-sum 3 and 2-sum 4 in the future. Alrighty, talk to you guys later.